Now I'm going to take you through how to do the calculations to calculate pH from the spectrophotometric pH data, measurement data that you will have taken. And so what you should be looking at to begin out with is a Google Docs sheet that looks like this, that has a few bits of information in it. First off, you have a column for the absorbances that you got, both after pH or after the dye addition at 434, 578, and 730, and then also before the dye additions for 434 at 578 nanometers and 730 nanometers. In addition to this, you should have a temperature and a salinity measurement for each of those as well. So what this would be is each one of these columns, or excuse me, each one of these rows is a different measurement, essentially a different cuvette or a different water sample, with then all of the different measurements taken, the temperature, the salinity, and then the three absorbances taken twice, both before and after the addition of the M cresol purple dye. So what this represents then is 1, 2, 3, 4, 5, 6, 7 different water sample measurements for pH. So to begin off with, we are going to download this data again as a CSV file just onto our hard drive, and then go into R. Now to begin off with in R, what we need to do is make sure that we have the packages downloaded to be able to run the spectrophotometric calculations. So first off, what we need to do is install two different things. We need to install DevTools and also Marelac, M-A-R-E-L-A-C. Okay, so we're going to hit enter on those, and R should go ahead and go through and install those packages. And I am going to load one of them, the library, DevTools. I'm going to get the command ready for that while we are waiting for those two packages to install. Okay, there we go. And I'm going to load DevTools. Okay, now once you have loaded DevTools, now we have to install the OTools package to actually get the actual function for the spectrophotometric pH. That is in a slightly different location. It's not in a normal repository. Instead, it's on GitHub. So we're going to type in the command install _ GitHub and parentheses and then quotation marks. We're going to type in Kurt onthank with the K and the O capitalized / OTools. The O and the T beginning it are capitalized, and then OO lowercase OLLS. Okay, we'll go ahead and run that command. And in mine, actually, it tells me that I already have installed and nothing has changed since the last install. But on yours, it should go ahead and install OTools. Okay, now we're going to load OTools. Library, OTools. Okay, and we load that package, and that has the spec pH. So if we want to see that function, the function that we're going to use is called Spec, S-P-E-C, P, and then capital H. And that brings that up here, the help path. So again, here are the commands, or here are the arguments associated with that, so we can use that as our reference here. Okay, so first off, I'm going to read in the data, so I'm going to type in just spec equals read.csv. Again, we use tab to look at that. So here is that CSV file. Enter that, and let's go look at that real fast. Okay, so here we go. We have temperature, salinity, and the absorbance readings. That is exactly what we need. Okay, so let's start reading those in. I'm going to type in the command, give myself some space there, spec, P and capital H, salinity equals, and then we're going to go spec $ this. And with all of these, since all of these run all the way down, we're not going to use like bracket 1 to only take the first element of any of these columns. We're just going to take the entire column. Okay, then we take temp equals spec $T. Okay, A434 equals spec dollar sign A434, A578 equals spec dollar sign A578. It's going to enter there. A730 equals spec dollar sign A730. Now we're going to the before die addition observances. B434 equals spec dollar sign B434. B578 equals spec dollar sign B578, and then B730 equals spec dollar sign B730. Okay. At this point, what we should do is go ahead and run this command, and what it's going to do is give us a string of pHs here. All of them look like they're fairly close. 8.0 rounded off 4, 8.05, 8.04, 8.02, 8.04, 8.03, 8.01. So they're all pretty close to each other here. Once again, if we want to go ahead and store this as an object, what we might do is call this pH equals that, and Control Enter, and what this will do is this will give us an object that is a string of those, so we can store that for later calculations. So that is how we go ahead and calculate spectrophotometric pH from the absorbances and the other measurements that we take of the seawater to get those. Okay.